Hey, good morning. You know what I just realized is that the photo in my Zoom is actually a mirror image of what you're seeing right now. See, because if I stop video and go to the photo of me that Zoom uses, it's actually the same T-shirt. Okay, it's the same T-shirt. But check it out. Okay, so if I go to the video, you'll see that the logo went off to the other side. But the logo is, but you can read the logo in left to right properly here. So the photo is not the mirror image. What is the mirror image then? So do you guys see now? You see the mirror image, right? So you can read the logo, right? It's right to left, isn't it? Or is it only for me? Is there a setting that I need to put in, select in Zoom to make sure that my photo is not left to right swapped? Why is it, does it give you an option to swap left to right? Sharing options. I don't know. Someplace, I think it may have a, I think there might be something there that says, mirror image your camera or something like that. Because as it is, I'm glad I'm not, typing on the writing on the whiteboard, because you'll see all my writing in reverse, right? Yeah, so I got to figure out how to fix it. But I know, fortunately, it's not getting in our way of learning, because you guys are doing most of the coding, and your screen is being shared, and it's all very clear. So. Again, we'll give other people a chance to join. If you have any questions in the meanwhile, I'm happy to answer them. Well, you know what? I didn't see anyone take that game to the next level. I was hoping that some of you would actually take it up and create a new game. Maybe just an embellished version of the race with more players, or even videos of two or three of you having a game in the STEM Center, and here are the results. So those would all be fun. So my only guess is that you guys are all overloaded with so many other courses, and you just don't have time for this. So yeah. So what we'll do today is search techniques. I'm not, like I said before, I don't want to cover linear search and binary search. They're very simple, and you're going to learn them in the quests anyway. You have to do them for homework. So we won't do linear and binary search. If you have any other questions regarding these topics, or any topic that we've covered so far, you should feel free to ask, and I will answer them. Otherwise, today my plan is, let's try and implement something. The gradient descent and descent technique that I talked to you about before. So we can do that today, and hopefully someone who's got, actually it doesn't matter whether it's a Mac or a PC, right? We can just run it on either machine. I think what we need to do is, before we launch into that, I'd like to talk a little bit about, the technique itself, the search technique itself, gradient descent, because it's a different search technique from other search techniques, right? So typically, when you're looking for something, you're looking for a specific item, right? So, for example, you have a list of student IDs, and you want to know, hey, what was Jaden's score in the midterm or something like that? So you're going to look in the list until you find the name Jaden and find the score and return it. Yes? That's how it works in a search, isn't it? So in search, you say, find this, find that, and so on. Yes or no? Okay, there's one other kind of search, okay? There's one other kind of search, which in fact is in the more important, and if I'm not mistaken, well, I can't make that claim, but it's hugely more important, and not more important, I can't say more. Usually it's very common. It's more common than people expect. It is looking for something when you don't know exactly what you're looking for. Okay. Have you ever encountered that problem? You have. I'm pretty sure you have. But I'm going to show you a problem like that today, and it's very simple, right? So suppose you have a distribution of items, a collection of items, and you want to find the minimum, right? And isn't that a search technique, to find the minimum of something? Because you're going to keep looking and find out, if it is less than everything else I've got so far. Yeah. And well, I'm not getting any feedback, so you guys are still sleeping, I guess, early morning class. So I will go very, very slowly until you guys have a chance to ignite your engines and join the convoy, as it were. So so you guys should just feel free to talk, and you shouldn't feel free to be, you shouldn't feel obliged to just, I have 2 hours to go and sit down and wait while he keeps talking, and then after 2 hours I'm free, right? So I don't think that should be the right approach. I'm not saying that that's what you guys are doing, but being participative and vocal always helps, right? Even if you're saying the wrong things, that's okay. But the important thing is, if you're participative and vocal, it means that you are engaged in class. You want to learn, right? As opposed to just punch your time card. Yeah, they used to say that, right? In the workers. So you just go in the morning and punch your time card and come out, but you actually didn't do any work. But so we shouldn't have our classes be something like that. So come here with an attempt to with the intent to learn. Okay, so if you have any questions, feel free to ask. I will answer them. Otherwise, today that's what we will consider. Okay, and in fact, we'll consider a way of searching in a continuous distribution. Discrete distributions, searching in a discrete distribution is a different. Discrete means everything is bent, right? Everything is an item, so you can basically put your finger on these items and say, okay, not that, not that, not that, not that. Yes, that's a discrete distribution. But what if you had a stream of continuous variables, right? Continuous meaning it's a solid number line, right? But it is a solid curve, right? A solid curve like that, and you want to look for some value in there. So it's not feasible to search individual values anymore, is it? Right? You can't search 1, 2, 3. What about all the values between 1 and 2? You didn't search those, right? But if you say, okay, now I'll search the values between 1 and 2 also, you'll never be done with your search, right? Because there's an infinite number of values just between 1 and 2. Yes or no?
Yeah. I think there are values between 1 and 2 for this to work.
Yeah, because it's a continuous floating point numbers. There's a huge number of numbers between 1 and 2. So you can't use the same techniques you use in discrete search to apply in continuous search, right? When you're searching a continuous variable, you need to apply some other techniques. So we will look at one such technique today, and it'll be very useful for you in future. Maybe not immediately. And in fact, we don't even use this technique in CS2B and 2C. Okay, 2B and 2C, there's a lot of advanced topics we'll cover, but strangely enough, gradient descent is not one of those. Why? Yeah, it's not in the syllabus, it's not in the CID, but I think it is hugely useful from the point of view of understanding concepts in computer science. Okay, that's the reason why I want to do that, because it's going to help you understand other concepts, not with a view to mastering gradient descent itself. You don't have to learn and master gradient descent, what we're going to talk about today. But in the process of learning about gradient descent, you'll learn about other concepts in computer science, and it'll solidify your understanding of those things. And also, build more intuition about what computer science is all about, what are the kinds of problems that computer science can solve, things like that. Okay, so we'll start in about 5 minutes at 8:15. Hopefully, one of you can pick up the screen and code. Adam just coded last class, Kiki coded, and then Kate, and then Jaden also. Jose, you can have another chance if you want. And Tim, you also coded recently, right?
Not recently. I was the first one.
Oh, you were the first one. But... Okay, so in that case, if Jose doesn't want to go, you can take the screen today. And if you don't want to go, Jose, you're able to go, right? You're able to take the screen. Okay. So let's give Tim the chance if he wants to go first, and otherwise you guys can decide amongst yourself if you want. Right, 8:15. One of you should take the screen, and we'll start coding. Okay, we'll start coding from a brand new, a fresh slate. We won't pick up last week's code because last week's code. Well, I keep saying last class's code, Tuesday's code is for you guys to take and develop to the next level. Okay, you should take it and make a game out of it, a proper nice game out of it. And there's extra credit attached to it too, right? Extra question credits. I said it's attached to it, and you should absolutely, take these opportunities for extra credit. And I hope you guys had a chance to pass the message on to the other students who are not who are not attending class. Okay, so I don't know. So Foothill, the admin people sent me an email saying, well, we should look at stopping. We should not have student discussions on Reddit anymore. We should only have it in Canvas, and possibly even not do questing and all. We should just do regular assignments in Canvas like other instructors, and maybe even stop teaching on YouTube, right? Just teach behind closed doors. So if that's the case, then I can tell you right now that since it's not even in the open, if the people don't participate, they will basically just fail, right? And the Foothill will have we'll end up with very low success rates, right? So if I'm teaching this class behind closed doors like I used to, like all the other instructors, and I have because I know when students are learning and I have these strict requirements, I'd be able to follow them more closely in one-on-ones and face-to-face meetings and discussions in Canvas that I can expect to have much more detailed notes. So it won't just be regular updates like we're seeing now. I will say every week I need a really detailed report of the experiment, and just like in chemistry and physics, and then I can grade people on that. And these people who are slacking off will basically just end up failing class, right? But on the other hand, the people who pass will be really solid. So I think so if I switch to the old way of teaching things again, I think it may actually work out better that in the sense that the ones who pass my class will be really solid, although they'll be very small in number, right? Compared to right now, it's like maybe 20 students pass class, or 25 students pass class, okay? And maybe 5 get A's and A pluses and things like that. But behind, the traditional way of teaching with the same kind of strictness enforced, but you'll have all the other help with STEM Center and all these other people. But at the end of the day, none of it is going to cut you, cut it for, grade if the output from the student does not match what is expected. So you can use all the support services to get your output to match. And so, I don't know, maybe 5 or 10 people will pass, and many people will just get C's, and GPAs will tank, and hopefully, not hopefully, yeah, maybe that will be a wake-up call to Foothill itself to make sure that all sections are taught competently, meaning that every instructor needs to teach all the material solidly. Can't just skimp on the material and skip hard topics and tell students to learn it themselves. So you can't do that, because everybody who goes on to the next class needs to know all the prep material, right? So maybe we'll start enforcing that more, so that people don't get the wrong impression. And right now, if you go to the Foothill Reddit on Reddit, you go to Foothill subreddit, or even Rate My Professor, any of these public sites, and you look at all the student posts. 90% of the students, they're not interested. It looks like they're not interested in learning. They're just asking, which class should I take in order to get an easy A, right? Essentially, they're asking, where should I go so that I can get an A without having to learn anything? And because professors can teach behind closed doors, there's actually a great value for these professors to just hand out A's without doing any work, right? Just learn it by yourself, and I'll give you points if you have put in the effort, right? You say, I've worked on it really hard, professor. I went to the STEM Center. So many people helped me. I didn't learn. I'm still stuck. That's the best I can do before the deadline, even though it gave me extensions and all. Well, you know what? The professor could say, yeah, okay, no problem. I'll give you full marks for that, right? And the student ends up with an A. It doesn't, do anything for the student. So, but on the other hand, the student would go away and praise the professor on Reddit and on Rate My Professor and saying, hey, this class is an easy A, very kind professor, always listens to you and gives you lots and lots of points, lots and lots of opportunities to succeed. Yeah, okay. But it's just that because it's easy for them, really. You come and ask me for points, it's easy for me to give you points rather than say, okay, no, tell me what you understand. I'll examine whether you understand it correctly and then give you the points. That's harder for me. So if I'm just going to take up my salary, which is your money, really, you're paying that tax and I get the tax as salary, right? And then you come and ask me for help. And I say, well, you know what, I'll just give you the points. And you go happy, hey, as a great professor, give me points and all. And you praise it and lots more people enroll in the class just because I give away points. Foothill will also be happy in a sense. If they don't do a deep dive and analyze why, students are happy, without actually finding out that all these students are happy having passed all these courses, but once they leave Foothill, they're screwed because nobody has any respect for their knowledge. These guys got an A, but they don't know anything. They can't code a simple program, and so never hire people that come out of Foothill College, right? That's the reputation that'll happen. That'll come out eventually if people just start handing out freebie A's. And but if that happens, then at some point there will be pressure from the top down, not top down meaning not from the presidents of colleges and so on, from the public, right? The public isn't really the top. Everybody in any institution, public service institution, whether they're presidents or the super presidents or whatever it is, they're all servants. They're all servants of the tax-paying public. So if the public says this is what needs to happen, they got to say that's what I will do. Thank you, sir. Okay. So when the pressure starts coming down on these institutions, saying, well, we're paying money, taxpayer money, and the institutions have to be beholden to us and teach our students what we're paying them to do, right? Rather than just give them A's, which I can get from anywhere. And so when that kind of sentiment starts, pressing itself on institutions, then I think that all classes and all instructors will emphasize learning over freebie points and skipping teaching hard stuff, which unfortunately I had students complain to me before that they had classes at Foothill from tenured professors and who didn't understand the material they were talking about, because the students went to ask them in their office hours, can you explain this to me? And then the professors were struggling with intermediate stages of the proof, even before they got to the place where the student themselves were struggling, right? The student got to a place where there was a bug and they couldn't solve it. And they went to the professor asking them to solve it. And the professor was not even able to get to the point where the student had the bug. And they were struggling with simple concepts, right? How could that happen in a public service institution where we're funded by your money, right? And these teachers right now have the luxury of teaching behind closed doors and not being examined in detail, so that they can basically do whatever the hell they want. And the unfortunate side effect is that students get affected at the end, right? In two ways, right? Well, either they would pass out of that professor's class and not go on to the next class in the same professor's sequence, right? Because the likelihood is that professor, if they teaches the complete sequence leading all the way out of Foothill, they could basically be teaching a slacking course all the way, right? I don't know hard topics, I'm going to skip all the hard topics, I'll just keep giving you A's for effort, right? And they go out and the students are going to get affected. They'll never get a job after that. And all the people like at Google and Microsoft and Facebook, they're going to say, this guy, these people are useless, right? They don't know the basics of fundamentals, from fundamental programming, and they want a job in a software company. What are they thinking, right? Or that's one thing that could happen to the students. Or instead they could do one easy section, like a freebie section like that, get an A+, and then end up in my section or someone else's section that is really hard. Right? Because I know, like you can look at past posts by John Vicino and other people who've done my classes. There it's on Reddit, right? And they've actually said that enrolling in my class was a wake-up call, because they got A+ all the way through, right? At 2A and 2B, and they thought they were solid, but then they had a wake-up call in 2C because they figured they had to go all the way back to basics and learn everything, right? But after finishing 2C, they said, I'm really confident about programming. Right, so there could be that situation too, where students who got these easy passes from professors who are slacking off, ended up in a hard section where they actually needed to improve their mental, and then they got C's or failed, even though they got A pluses all the way leading into the class, right? So again, that affects the student, their GPA is tanked, and all those problems appear. So we don't want that to happen, because at the end of the day, we are your servants, okay? That is the important thing you have to remember. You have to treat me as a servant, right? I am your servant. I am not your boss. I'm not. So when people come to classes and say, hey, professor, he's going to tell me what to do. No, actually, I'm not telling you what to do, right? You told me what to do. You told me, hey, prof, I paid $270 for this class, right? So give me the goods, right? So you can go to Walmart or, or Trader Joe's and say, well, you know what? Right? They can say, I've taken your money. I'm not going to give you your, carton of milk now, right? Like that. You've paid the money. Now you need the goods and you need to demand it and get it. And so if I'm not teaching you something, right? You can't just say, okay, you know what? I went to the bar and I paid them the money, but, bartender is taking a long time to pour my beer. So, even though I paid my money, I'm going to go somewhere else. Do you do that? No, right? You say, well, it's been like 10 minutes since you took my money, man. Pour me a pint or something like that, right? So like that, if you're in my class and you're not getting the value that you paid for, it is up to you to complain to me and say, hey, what's going on? Teach me what I paid for, right? I need to learn about such techniques. Because in my next class in 2B, I'm going to have to use these techniques. And if I'm struggling there, it's because of you. It's because I paid the money and I didn't get the value from you. I'm struggling there, right? So it is up to you to make use of your servant, right? I am your servant, right? For all practical purposes, I'm a servant here, because I'm serving you for paying me to teach you these skills. Well, there is something in it for me too, because I get a lot of excitement about seeing young people like you, kick the ball out of the park. Okay, so when you guys do something really, really cool, right? It just makes my day, right? And I can see these things, even interesting Reddit posts that you make. I can see, right? These are people who are actually going to, well, in 10 years from now, I know, right? On Reddit and so on and so forth. I know, right? These people I need to watch in 10 years. Okay, because in 10 years, those people are probably going to be in the news because they made some huge change that is affecting the whole world. In a positive way, right? And and those are the things that professors look for and say, well, you know what? We've had a great run. We've done a lot of cool things on Earth. So now let's see if other people can also do it and watch those people, right? So it's because there's an infinite number of people. You can't watch everybody. You want to watch the interesting people to tide over the rest of your life, and so that's where this comes in. So please ask questions and get your money's worth, okay? Because I'm not here to just keep talking on and on like this. Look, already I wasted 20 minutes just talking on and on about this because nobody is asking me any technical questions. And so the important thing is that, you guys are here. Be more vocal, but pass this message on to the other people, right? Cutting class is going to actually incur penalties from now on, right? From now on. And I'll see if I can enforce this for the rest of this quarter, but I will certainly start putting it into my syllabus for next quarter. So if you're enrolled in a proper section and you're not making it a class, that's basically, points off. And, and they also have to attend class and ask questions and be participative like you guys, okay? Take the screen and drive. And I'm sure Adam can testify to this. Last class was fun, wasn't it? You actually had, right? Yeah, it was fun and it was useful too, right? I hopefully you picked up a few things in programming that you were not as comfortable with before, and then it became more and more comfortable along the way. And yeah. So all of those are very useful skills to pick up. And besides the fact that you are helping me out greatly by typing on my behalf, okay, right? Because if I type, it's bad on 2 counts, right? My wrist will start aching after the first 10 minutes. And then you won't get practice and I'll be typing at a different speed. I won't know where you are struggling. When you're typing and I'm talking about what needs to be typed, I get a out of band message automatically without you saying anything. Just by watching you type, I get a subliminal message saying, that is a place where students struggle, right? When Adam has, is hesitating whether to put a curly brace or a square bracket, I know, right, immediately, okay, that's a place where many students will be having the same question, okay? And then I can zero in on these things. Whereas imagine, right, if I was typing instead of Adam, but I'll just go ahead and type, bam, 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 like square bracket, curly brace, everything falls in the right place, except, typos where, physically I don't notice some things. And then you'll miss out on the opportunity to learn the places where that constitute the most frequent stumbling blocks, right? The places where people stutter most. And if by watching an experienced violinist or piano player, you don't understand, well, at least, um, we don't tend to learn, we don't tend to learn the places where a particular piece is especially hard. Because for them, they've practiced that, right? When I watch my daughter, so there are many pieces, they are easy for a while, but there's some sections, like 4 or 5 measures, that are like super duper challenging, right? So she might like practice for 3 hours on an entire piece, but of the 3 hours, 2 hours were basically just 2 measures of the entire piece, right? Everything else basically flows, but those 2 measures are the really hard ones, right? But but the thing is, but I know, because I sit through her classes, I know that when the teacher actually told her that, well, this is the whole piece, but this is where you're going to be practicing most of the time, right? And that was exactly where she was practicing most of the time, because the rest of it comes easy, right? And how would you know that if she only watched this teacher play, right? She might be, so I think a good approach is for you to code and then for me to watch. That way I can find out places where most of the students will stutter. And it's also very valuable knowledge that we're leaving for posterity too, right? Because when people later on, or me myself, in a later section, suppose I took a break from 2A, right, for a couple of quarters and then decide to teach again, I can watch this video, these videos, and see, well, what are the most likely places where students get stuck, right? Those are the places I should emphasize more or go slowly on, right? And or drill more into, and so on and so forth. So those are very super duper helpful for me, these videos also. Right? Not that I watched, because I remember all of them already, but I'm thinking of a time when I could have forgotten these things and I have to watch to, review. Okay, so if nobody else is, so it looks like nobody else is going to join yet. I don't know why attendance is flagging. Okay, I'll make a note, right? I'll post a note in Canvas. I'll post an announcement in Canvas. Those people who are in the regular section but are not attending class and not also letting me know beforehand, they will be suffering point losses in their grades. So I'll post that. All right. So Tim or Jose, just take the screen, and what we'll do is let's do a Chrome window. Incognito Chrome window or Safari window, private Safari window. And before we go into online GDP, I'll introduce a problem, okay? I'll introduce the problem and say this is what we want to try and do, okay? Either of you can take the screen. Tim, thank you, Tim. Okay. All right. Now, how many of you have used this incredible piece of software called Desmos, right? I don't know if you're enrolled in math, but if you're enrolled in a math course in a college or even high school, it's invaluable. So are you familiar with Desmos, DESMOS? No? Oh, wow. Okay, I'm surprised. Okay, so open a tab, go to desmos.com. No, it should be DESMOS. Okay, now let's. There should be something called graphing. Click on graphing calculator. Okay, great. All right, so this is incredible, right? I mean, it's very nice, and the thing is, before Desmos came on, appeared on the scene. I've been wanting to, ever since my student days, when I was like you guys, okay, I've been wanting to do something like this on the side, okay, not as part of my main job. I've been trying to do something like this for, well, a long time, 20 years, 25 years, but it's always been in the back of my mind, okay. I'll do it next week. And all of a sudden Desmos came out. And I thought, wow, this is exactly what I wanted to do, right? So I don't have to do it anymore. It's beautiful. Okay. Any equation you want, you just type it in the left. In that type in the left, y equals 2x plus 5, and you'll see the equation. There you go. That's your y equals 2x plus 5 right there. Okay. And in fact, mouse over the line, and click any point. Click any point. You'll see that that's what it is, right? Take the y value and x value. Yeah. Take the x value and 2 times the x value plus 5, you'll get that y value, right? Any value, right? So minus 2.5, yeah. So that's minus x equals minus 2.5 times is 2x is 2x is 5, so minus 5 plus 5 is 0, right? So that's why. So so you see, this is Desmos. Now let's draw a more complex curve in Desmos, okay? So let's draw. We'll stick to parabolas initially. Right? Obviously you can also do cubic equations. Like so, let's hit enter and let's draw another curve. Let's say y equals 4x to the 4 plus 3x squared plus minus 2y cubed. Oh no, yeah, minus 2y. Oh, actually, we missed out with the cubic term. Make the 3x squared 3x cubed minus 3x cubed minus 3x cubed. Minus, yeah, and then plus 2, 2y squared, and also add a linear term, x and a constant term. Yeah, okay. Yeah, okay, well, all right. So now, can you shrink, pinch, or I don't know, how do you do this? Yeah, all right. More. So what color is the second one? Oh, that's too much. Yeah, get rid of the red line for now. Yeah, get rid of that. Okay. Oh, that's got too little. Can you make it bigger? Go to the place where they intersect. They're not supposed to intersect. How come we have 2 distinct curves? Can you zoom out all the way? I don't think they're supposed to be 2 distinct curves. It's one continuous curve. All right. Well, okay. We'll do a simpler curve. Okay. We'll just do get rid of the 4th power term. We'll just do 3 powers. No, 4th power, x to the 4. X to the 4 can go, and then add the quadratic and other terms. Yeah. Minus, all right. 4x minus 3x cubed. Oh, where's the curve? Where's the curve gone? Y equals 4x minus 3x cubed is not even shown on the screen. Hit enter at the end of the line. Oh, it says there's an error. Why is there an error? Why is there? I got to increase the size maybe.
Superscripts cannot be empty.
What? 4x. Oh, I think it says you have a subscript there. Let's just say 4x squared there.
There we go.
Okay, now you can pinch out, and I think. Oh, because it's a 4th power. Yeah. Okay. No, that looks better. Okay. Yeah. I'll still change classes. Okay. Okay, so suppose you have a curve like this. Now, this is just a 4th power term, right? And already you can see that the curve is like this, right? It has a maximum and a minimum, and then there's infinity on that side and infinity on the side. Now, suppose if I give you a curve like this and say, what is the minimum value of this curve? Obviously, there's a minimum value is negative infinity. You can't find it. So let's pick another curve which actually has a minimum or a maximum. We can try and find it. Okay. So now let's say y equals on the next line. Yeah. Get rid of this curve. We don't want this curve. Okay. So let's go with a general regular quadratic equation. Right. So let's say y equals I don't know. Just put in a regular quadratic equation. Choose numbers for ax squared plus bx plus c, where you just say a 3x plus 3x squared plus 2x plus 7 or whatever it is, right? Or minus or something like that. Create a quadratic equation right there. No, it has to be. No, you can't say a. It has to be an actual value. It has to be a number. It has to be like 4x squared or something like that. Plus, add a linear term also, plus. Well, what you had was fine. 2x squared plus 4x squared plus 2x plus 7. 2x plus 7. Yeah. All right. Okay. So now this is a parabola, right? You can zoom in and you can see that get rid of the 7. Let's take a look at the behavior of the curve first. Okay, get rid of the 7 first, and we'll actually see what the effect of all of these things. Okay. Now, why is it dipping below? Why is it dipping below? Oh yeah, of course it dips below. All right. So because the 0 is not there, right? Even in fact, get rid of the plus 2x also for now, right? Get rid of the plus 2x also. Okay, now it is tangential to the x-axis. Now that is your x squared curve, and get rid of the 4 also. Let's look at 4 y equals x squared. That is your basic parabola. Okay, that is your basic parabola. Everybody in math, you guys understand what I'm trying to say here is, are you guys enrolled in math? You know about parabolas, right? And quadratics? Yes or no? I know Kate is nodding her head. Adam, Jaden, are you comfortable with parabola and all? Kiki, Jose? Good. All right. So this is a parabola. It's a quadratic equation, y equals x squared, and it is just touching the x-axis. Now let's say x squared plus 5 and see what happens to the curve. But before you do plus 5, okay. So when you do x squared plus 5, you can see that the whole curve just went up. Yes. So because every y value, whatever you calculate without the plus 5, you're just adding 5 to it. So the curve just goes up. Now you can play around with this in Desmos and get and satisfy your own curiosity to build up a solid intuition about what happens to the curve when you modify the equation, right? You got to try lots and lots of equations like this. You do minus 5, it'll go down, plus 5, it goes down. Now you try one more thing, get rid of the plus 5. And instead of x squared, you say x plus 2 the whole squared. Okay, x plus 2 the whole squared. No. Instead of x squared, instead of x squared, you say x plus 2 the whole squared. X plus 2 and the whole thing squared within brackets, right? Within parentheses, the whole thing squared. You'll see that the exact same parabola. No, not 2 squared. The whole thing squared. Yeah, and you have an empty exponent after 2, so you got to get rid of the empty exponent. Okay, all right. So now you can see what happened to the curve, right? You added the 2 to x, not to y, which means that the parabola got shifted here because the actual value that is being squared is 2 more than what was what the value of x is. Yes. You can obviously experiment a lot more with more slightly more complex parabolas, like 2x squared plus 5x plus 3 and minus and so on and so forth, and look at the shape of these curves. Okay, now this is a very, very simple curve, right? It's a very simple curve, and it's easy for us to visually identify where the minimum of this curve is. Yes or no? Right? What is the value of x for which the minimum value of the curve occurs, right? What value is that curve? For what value of x is the value of y the least possible value? The minimum value of y for what value of x is what I'm asking. Right. Well, Tim's got his mouse pointing to it, but ideally, I'd like for someone to also be vocal and speak. Okay, and say. So what is the value other than Tim? Someone tell me what value of x is the curve, is the function got the lowest value for?
It seems x will be at the lowest value will be -2, and I guess if you also want to know why the low it seems x at 0 also equal to 4, and that's going to be an important thing to point out as well.
Oh, I'm sorry. What were you saying? I missed the second part of what you were saying.
If it's also going to be important to point out, x at 0 will be equal to 4 up there.
Yes, x at 0 will be up to 4, equal to 4. So obviously the least value of the function is not x at 0. So it is. Is that what you said? At -2 you get the least value, and no other place you get the least value. Is that what you said, Jaden?
Yeah, that's what I said.
Okay, all right. Because I didn't quite understand what you said about the 4 thing before. Right. So if someone gave you a curve like this and said, what is the least value, right? What is the least value of what is the value of x for which the function has the least value? How would you find it? So here's a problem, okay? Here's a problem. And let's do the analytical way. Analytical way is mathematical, right? Mathematical means there's no machine learning and empirical testing here. You just say, I mean, derive it. This is the absolute truth, okay? So mathematically, if someone said, how can you find the least possible value of x plus 2 the whole squared? How do you do that? One way, of course, is to do what we did, which is to plot the curve. Yes, we plot the curve and then visually inspect the place that is the least value and say, hey, at that point, like Tim said, Tim moved the mouse and said, at that point, x equals -2 because the function is 0. And I can see that the function that's the least possible value. It's not below that. Yes, because you can zoom in and say that's one way. Suppose you couldn't plot the curve. Suppose you couldn't plot the curve. And in this case, right, and this is like super duper important. In this case, it's a simple curve. It's a parabola. Yes, we can easily visually inspect it and tell. Now, once you're comfortable with this, you're going to take the same technique and apply it in a place where the curve is so complex that you can't visualize it. So you may have a curve. Already we saw that other curve, right, x to the 4, which had a funky shape. Yes or no? Already, and that was already a very simple equation. A simple equation already had a funky curve. But you can have equations that are very, very complex, involving trigonometric identities, x equals y equals e to the x plus sine squared x plus 3x cubed minus I don't know, a whole bunch of terms, log sine x and things like that. Okay, you have a really complex function out there. And so someone says, what is the least possible value of the function? How do you find out? And in practical situations, right, it's even worse than that. It's even worse than that because here we're only talking about one variable, okay, as x, y equals function of one variable x. Yes? So we can say what is the minimum value of y for changes in the one variable x. However, in real situations, in real life, when you see something happen, is that the effect of one thing changing? In real life, everything we see is a result of lots and lots of causes. Yes or no? It is very rarely the case where you see something so simple and mathematically pure like a parabola, which there's only one thing that's affecting this. No, right? It's like humans. Everything we do is conditioned by millions and millions of things that happen. So in real life, when you try and model a realistic situation, like a car driving, right, through a busy street, there's so many signals, and each signal is a variable. So then what you try and do is, I want to generate a function, okay, which gives me the error. Take a classic example. You're driving a car, right? And you define the error as a move of the steering wheel that could run the car into the sidewalk, okay? Or hit a pedestrian or something like that, right? So a wrong move in your car is going to generate an accident, okay? So that is your wrong move. And so let's say that so these wrong moves are actually a function. The wrong moves are a function of what my visual apparatus, right, the camera sees in the road ahead, what the visual apparatus of the camera pointing backwards, visual, pointing this side, sound from here, okay? So many different factors coming in, right? Traffic lights, all of these. So each one is a different variable. So you don't have y equals, function of x. You have y equals a function of x1, x2, x3, x4, so many variables. In fact, in machine learning, we learn to handle functions that have an infinite number of variables, meaning y is a function of an infinite series of x's, right? And so you have so many of these variables coming in. How do you find the minimum? How do you find the minimum of the error, right? So I want to say my error in driving is a function of all of these variables, which can all change independently, right? Because as I'm driving, people coming in and out, that's independent of the traffic lights. right? And what's happening behind me, again, that's independent. So there's all these independent factors, variables that I have to consider when I have to generate the value for this function, which is gives me the error, likelihood of the error when I'm driving. Okay, very simple use case. So I say, well, I've got a function, and that function tells you what is the likelihood of the error. If it is 0%, you're safe. If it is over the 50%, you should basically stop the car and reevaluate, things like that. So those are the kinds of decisions that auto driving companies make, right? So if that is the case, and you have this surface, in this surface is not even a simple, now it's a line here on a two-dimensional screen. But the moment you have two different variables, x1 and y1, x and y, and z is the error, now already it's not a simple line, it's a surface, isn't it? It's a three-dimensional surface, isn't it? If you have three variables in a three-dimensional plane, and one of them is your control, two of them are your control variables, and one is your observed variable, you already have y equals a function of two variables. So you have a surface. How do you find the minimum of a surface? The surface could be undulating, and it could be like that. How do you find what's the lowest point of that surface? How do you find that? Because if it's a 3D surface, maybe you can plot it in a three-dimensional graphing software like AutoCAD or something like that, and you can rotate it in Mathematica and look at the surface and say, okay, well, that's where the minimum is likely to be. Yes, you can do that. But many times the surfaces are not even three-dimensional, right? The surfaces are in n-dimensional space because there's so many variables, like 5, 10 different variables, right? How can you model the surface in n-dimensional space, in higher dimensional space, right? And still find the minimum value or maximum value in there. So this is a classic machine learning problem, okay? And it is not out of reach for CS2A students because we can take the same concepts and say, well, let's not look at high dimensional surfaces now, because it's exactly what you're going to do now. It's an extension of this technique in high dimensional space. We'll just take the very simple version of it, which is a single dimensional y equals a function of x. And again, in that, we'll just take a parabola and say, well, this is a parabola. Now, if I didn't have the luxury of looking at the parabola plotted on a piece of graph paper and saying that's where the minimum should be, can I find the minimum? Right? One way to do this is analytical, right? Analytical saying, well, you know what? I look at the parabola and I can see that it is a curve. It's not a line, right? If you can, hey, Tim, can you zoom in slightly so that you can see the curve? It does look like a curve. Anyway, yeah, that's fine, right? Yeah, thank you. Right? It's a curve, and you can see that the slope of the curve is different at every place. Yes, because a line has the same slope everywhere. Yes or no? A straight line, same slope anywhere you go, right? No matter where you go, it's the same slope. Yes or no? Okay, Kiki's not nodding her head. Jose and Tim, I can't see. Kiki, yes or no? A straight line, same slope, no matter where you go, right? Meaning that no matter where you go, the rise. Does everybody know what a slope is? Does everybody know what the slope is? Slope is basically a gradient. Okay, gradient is how steep it is. If you're driving a car and if your road is very highly sloped, right? Like in San Francisco, and you know that it's very steep. So slope is a measure of how steep it is. Now, how do you calculate the slope? You can calculate the slope by saying if the run over the rise is how we define the slope. But intuitively, what that means is for a certain amount of progression in the horizontal direction, how much did I have to increase, right? How much did I have to progress in the vertical direction? So if I had to progress only this much horizontally, but in going from here to here, vertically I went that much, then that means that my slope is very high. Yes or no? Yes. On the other hand, sorry?
Sorry, you said the yes or no on if it would go high?
It would go, the slope would be very high if I had to travel very little horizontally, but that little horizontal motion made me go very high. That means the slope is very high. The slope is high, isn't it? It's very steep. Slope is high. On the other hand, if I had to travel a long distance horizontally, but then vertically I only managed to go that much, right? Then what does it say about the slope of that road?
That it's not steep.
Yeah, it's a low slope, isn't it? Low slope.
Yeah, it will be in shorter bursts.
Right, it's a low slope. And if the road is perfectly plain, right, I travel horizontally as much as I want, but I never travel vertically, right? I can keep going horizontally, but I never, no vertical displacement at all. What is the slope? What is the slope if I can keep traveling horizontally without making any vertical movement? Why is my internet connection unstable? Can you guys hear me?
We can hear you now.
Oh, okay. Please let me know if I'm cutting out, okay? So what is the slope if I can travel vertically for a long distance, but never travel, travel horizontally for a long distance, but never manage to make any vertical progression, right? I'm just traveling horizontally. That means, well, what does it say about the slope?
It's non-existent in that case.
Yes, thank you, thank you. The slope is zero. The slope is zero, isn't it? So using these intuitions, we basically define the mathematical concept of slope, saying that the slope of a curve or a slope of any line is basically the run over the rise. So now let's plot a line on the next line, say y equals 2x plus 7, right? 2x plus 7. Okay, all right. Now this is our line, and let's say we want to calculate the slope of this line. What do? Right? So the slope of this line, so if you go right to the bottom where where it cuts the x-axis, right? You can see that going from negative negative 3.5 to 3, right? Going from negative 3.5 to 3, you go 0.5 on the x-axis. Yes. But when you go 0.5 on the x-axis, you've covered 2 units on the y-axis. Yes or no? So if you take the ratio of the rise over the run, that is defined as a slope. Now in this case, because the thing is, the curve is angled like this, and you're going from high to low, going from left to right, right? Left to right. We're going to say that the rise is actually negative, right? So when we travel in the x direction, right, the rise is not positive, the rise is negative. It's going from, what is that, negative 3 to, no, what is the value, the y value where you have, oh, it's 1, is it? What is the y value there? It's 1, is it?
Yeah, it's 1.
Oh, okay. All right. So y goes from 1 to 0. So it's negative 1. Y goes from negative 1 to 0. So that's negative 1. Whereas x is gone from minus 3.5 to minus 3. That's 0.5. Yes. So the slope here for this line is 1 over negative 0.5, or negative 1 over 0.5 is 2. Would you agree with that or not? That means that once I've calculated the slope, that should be the same no matter where I measure it. Okay, if you take the same measurement at a different point in the line, you'll get the slope is 2. Right? You take the same measurement elsewhere, you still get the same thing, right? So if you move up the line, move up the green line, more, anywhere, right? Yeah. Okay. So yeah, right now, even if you calculate the slope there, you'll see exactly the same value, right? So if you go from here to here, you'll see that one negative unit of y movement corresponds to half movement in x, right? So that is what characterizes the line, and that is called a linear equation for that reason. Okay, linear is line, so that's a linear equation, and a line has the same slope no matter where you measure it. Yeah. Okay, now let's go back to a parabola. You can remove this line and zoom out, and so we can look at the parabola. And so So now here, I can do the same technique, right? I can just do a run over rice because it's a curve. It's changed, the slope changes all over the place, right? If it's a curve, the slope is constantly changing. It's not constant, right? The slope is changing all the time. So how do I find the minimum here? Well, technically, because the slope is also changing here, you can apply the same technique here also, except that you have to zoom in. You have to zoom in so much that the parabola doesn't look like a curve anymore. You've zoomed in so much that it looks like a straight line. So you take any place in the parabola and zoom in until it looks like almost a line. Yeah, all right. Yeah, that's fine. Go to the vertical places, the place where it's, no, not so much. Not so much. No, you can zoom back. Yeah, back, more. And then let's go to a place where, no, bring the curve back. Bring the curve back into the picture. I think you zoomed out too much.
Not quite sure what you're asking. Like right here?
Oh, bring the parabola back into the picture. Bring the parabola back into the picture. No. Zoom back to the whole parabola. Zoom back to the whole parabola.
Right here.
Oh, all right, good. All right, so if you zoom, and if you don't zoom now, if Tim scrolls or pans to the place in a different place of the parabola, you can see that the slope you calculate there will not be the same as a slope here. But however, if we go zoom right in to let's say where it cuts the place where it cuts 4, you pan where the line cuts 4, make that there. All right, yeah, that's fine, right? So now it looks like a straight line, right? Don't zoom anymore. No, please don't zoom anymore. Yeah, that's great, thank you. Right, so now it looks like a straight line, right? It's only because we've zoomed in so much that it looks like a straight line. So calculus is a technique in mathematics where it says even if it's a curve, you can still find the slope of the curve instantaneously at any point by zooming in infinitely, so that when you zoom in infinitely, it looks like a straight line where you're looking at. Right? So and I don't want to go into the details because it's going to be a math class. I can teach it to you in a separate off schedule class if you want. But you can get the slope of a curve by taking the derivative, right? If you take the derivative of this function. Are you guys familiar with the derivatives in calculus? Or we won't talk about that, right? We won't talk about derivatives in calculus. I'll show you how to do this without. Are you guys okay with derivatives? All right, let's not talk about derivatives. If you want me to, I can connect it to how derivatives and calculus are connected to this, okay? All right, so suppose you didn't know what the slope was and it's minimum was, and you wanted to find the minimum. How do you do this? Now, here's how I would do it, okay? So now go back to the whole parabola again, Tim. Thank you so much. Thank you, right? I'm very patient with this. Here's what we're going to do. There you go. Thank you. Right now, this is a cool thing. You can pick any point on the parabola, calculate the instantaneous slope there. And how do you calculate the instantaneous slope? One way you can do it without knowing calculus at all is to basically find the y value. You take two tiny x values, like x. You take, let's say, 2 and 2.1, 2 and 2.01. You pick some small number like 0.1 or 0.01, 2 and 2.1, and find out what the y value is here, or what the y value is here, and what the x and x are. So you can find what the slope is at that microscopic location. Yes, and you know whether it's negative or positive. Now, one thing you can do, here's the interesting part, okay, where computational thinking comes into play, is that if you zero in and take a tiny measurement of the slope, empirical measurement of the slope, and say, well, at this place, the slope is negative, then you know that the minimum of that curve has to be on your right. Now, that is a very important statement. Now, if you understand that, let me know. If you don't understand that, also let me know. If you take a measurement of a slope and the slope is positive, right? The slope is positive, it means that the minimum is on your left. If the slope is negative, it means the minimum is on your right. And if the slope is 0, what does it mean?
Means that you've reached a bottom or top of the slope.
Yes. Thank you. Thank you. All right. And also, I liked the way that Tim worded this answer. That means you have reached a minimum or maximum. Okay. Because it's not the minimum or maximum, because in this case, a parabola has only one minimum, right? But you have curves like this and many minimums, many maximums. How do you know which one it is? So you can, right? So what Tim said is actually the precise and correct answer, that you've reached a minimum or maximum when the slope was 0. Now, this part is like super duper critical for you to understand, is that when you take an instantaneous measurement of the slope of any curve at any point, for which you don't need to know calculus, you only need to know the equation of the curve, right? Because you can calculate for a tiny amount of x change, what is the corresponding change in y? So you can calculate an instantaneous slope there. It's going to be approximate because you're not using calculus, you're just using empirical measurements. But still, the value of the slope tells you whether your minimum is on your left or right, yes or no, because this is like a super duper important point in machine learning and search techniques, advanced computer science also. If you are comfortable with this, you'll be like, very easy when you learn this advanced concept later on. So I want to know, right? Get a feel for whether this kind of thing is within the grasp of CS2A students, which I think it is, right? If it's not, you should let me know. So this is an important point where I'm saying that if you are given a random curve, right? Some random curve, you can't even, right? Like, we can create a random curve right now, right? Yeah, throwing an x and sine x and y, a whole bunch of functions that is very hard to visualize. You see Desmos plot this funky looking curve. Okay, all I'm saying is that if you want to find the minimum value, we can do it computationally just by going to a random location on the curve, picking a point, say x equals 7, just pull 7 out of thin air, right? And find what the slope of the curve is at x equals 7. And you can find the slope without having to take the derivative by just taking, well, at x equals 7, this is the value of y. So what is the value of y at x equals 7.01? Okay, you get another value for y. Now you have, y1 minus y2 is your rice, and x1 minus x2 is 0.01. So you can get the instantaneous slope at that point, and you can look at the sign of the curve, right? So a sign of the slope, and say, hey, it's negative. That means I should move more to the right. Now, this is the intuition, okay? Now, using this intuition, without knowing calculus, okay? It's the beauty of it. Without knowing calculus, using this intuition, we can find the minimum value of functions. Now, that's what we're going to do today. And this technique is called gradient descent, okay? It's a fancy term, right? People say gradient descent, gradient descent. What is gradient? What can someone tell me what is the meaning of the English word gradient? What does gradient mean?
Does it mean change? Maybe, I don't know.
All right, okay. Looks like nobody else have any idea what gradient means? No? I'm surprised. I'm so surprised. Okay. Hey, Kate, you don't know what gradient means? Do you know? Jaden, Tim?
I think it has to do with the steepness.
It is a steepness. Yes, thank you. In fact, gradient is just a fancy word for slope, right? It's a fancy word for steepness. So in fact, gradient descent basically means steepness descent. So you find the steepness, and if it's negative, go to the right. If it's positive, go to the left. That is gradient descent. Okay, so that's what gradient is, right? Hey, Google, define gradient. It doesn't answer.
Here's a result from search.
Oh, wow. Hey, this is really cool. So recently I switched from Apple, iPhone to Android, and I said, I'll go for a Pixel 6. And obviously, it's a switch between Google and Apple universe is a big thing to make for most people, because there are two different places in the spectrum of user, right, experience. Apple is, all rock solid, never crashes, phone never crashes and doesn't malfunction. But usually the technology is at least, a few months earlier than Google. Google is always at the bleeding edge. So you get a lot of really cool stuff. So I got the answer here, and that's because, if I didn't have my phone here, Google would basically speak out the answer there. But the cool thing was, I asked a question. The problem is, after switching here, because I'm on the bleeding edge with Google, the phone crashes and does crazy things. I have to put up with that, but I'm willing to live with that because the cool stuff is much more worth it. Because the other day I asked Google, there was a bird sitting right there, okay? And I said, hey Google, what common backyard birds have a red chest?
On the website.
Geez, oh, I'm sorry. Hey Google, stop. Hey Google, stop. Hey Google, stop.
Red or orange breasts.
Hey Google, stop. Okay, all right. So anyway, what I was trying to demo was as soon as I asked a question.
Sorry, I don't understand.
Hey Google, stop. As soon as I asked a question, it said, I sent a photo to your phone. Take a look, and it was right there. Immediately, I saw the photo, and it was the exact bird sitting there. So it's so cool. And this, technology, it's just having to straddle two different universes. That's a little bit of a bother. But anyway, so where was I going with that? A gradient is basically just a slope, right? It's just a fancy word for a slope. And when people say we're going to use gradient descent in machine learning, all they're saying is that we have a function for the error in terms of these variables. We want to find the slope of this curve and just follow the slope so that you get to the bottom of it. That's all it means. Now, that's what we're going to do here, right? Now, this is the intro to what our program is going to do today. So in our program today, we will be given a curve, right? Some random curve like x squared or something like that. We're going to pick a random point on the curve and then calculate the slope there. And based on the slope, we're going to keep making small adjustments until we get to the minimum. Okay. So now I hope that's enough of an introduction. So Tim, if you can open up your online GDB window, we can start coding. And yeah, let's put the customary comments and say a class code for today's date, and then we'll put a comment saying this is an experiment. Experiment. We will try and find the minimum search. We'll try and search for the minimum value of a quadratic function using on the next line. On the next line, you can say using a technique called gradient descent, which is just a fancy way of saying descend the slope, right? Descend the slope. Descend, yeah, descend the slope. Okay, so that's what we're going to do. D-E-S-C-E-N-D, C-E-N-D, C-E-N-D, yeah, descend the slope. All right, so this is what we're going to do. So now, again, here we won't use objects and all this class. Okay, we'll just do, because it's conceptual, and we'll just do this, okay? So on top of main, let's put in just a standard equation there. So on top of main, let's say this is the equation for which we'll try and find the minimum, okay? So yeah, put a comment there saying our equation, yeah, this is the equation, yeah, that's fine, for which we want to find the minimum. On the next line, you can say y equals, yeah, oh, no, comment inside of comments. Y equals, now I would like someone, oh, thank you, Tim, right? I like it when, we line up the spaces on the left of the, on the comment thing too, right? So I would like someone to just speak out a quadratic equation, okay? Involving, x squared, x and a constant term. It should all be, and you can have negative terms there too, right? It could be minus 4x squared. No, yeah, all right, no, don't use minus 4 for the x squared term. So the x squared term should be positive, x squared, and maybe you can use a negative term, x squared minus some number x plus a constant or a minus a constant, okay? So someone, I don't want it to be my equation because I'm the only one talking all the time, right? Someone who hasn't been talking and not Tim, and hopefully not Jaden or Adam, should, which basically just leaves Kate and Kiki and Jose, right? Should speak out a quadratic equation of any kind, right? Any kind. We can make fine adjustments to it afterwards if necessary, but I just need a quadratic equation there. And that's the equation for which we're going to try and find the minimum, okay?
6x squared plus 17x plus 32.
Okay, great, fantastic. Right. Thank you, Kate. Thank you. Can you type that in, Tim? 6x squared plus 17x Was it minus 32 or plus 32?
Minus 32.
Minus 32. Okay. 6x squared. No, it was 6x squared. X squared minus was it plus 17x minus 32? Yeah. All right. Thank you. Yeah. And then excellent. All right. So this is what we're going to find the minimum of. Now, before we do it computationally, how many of you know to do it using calculus? Do you know how to do this using calculus? Raise your hand if you know how to do this using calculus. If you don't, this is one line. I'll show you how to do it in the next line, right? If you already know how to do it in calculus, please raise your hand. We're not going to, yeah, thank you. Great, at least a few of you. So I'll show you how to do it, but we're not going to do it using calculus. We're going to do it computationally, which is very different, okay? So here's how. So what is the derivative of that equation? So on the next line, open a comment. Open a comment on the next line. Yeah, enter comment. For verification, type in for verification. For verification, here is the answer we should get. Here's the answer we should get obtained using calculus. Okay, so on the next line, you can say dy by dx equals, who can differentiate that for me? Can someone differentiate it for me, or do you want me to do it? Dy over dx. Yeah, no, not the dy over dx. Yeah, dy over dx equals. What is it? What is the derivative of that? Can someone tell me what the derivative is of that equation is?
12x.
Thank you, Kiki. Yeah, okay, Tim, you can type in what Kiki's saying. No, not, she said 12.
12x.
To a 12x. So, and?
Plus 17.
12x.
Thank you. All right, so that is the derivative, right? Isn't it? Does everybody understand? That is what is called the first derivative of that equation. Dy by dx is 12x plus 17. Now, the derivative is also the slope, because dy is the rise, dx is the run, isn't it? Dy is how much you increase on the y in the y direction. Dx is how much you move in the x direction. So the ratio between them is basically the rise over the run. Except that dy and dx are so tiny, you've got to use an infinitely powerful microscope to get to that place. So it's basically done what we're going to do in computer science, except shrunk infinitely. So dy by dx is basically the slope. Therefore, now we know if the slope, that is the slope. So 17, what is it? 12x plus 17 is actually the slope of the curve at any point. So at any point you plug in the x value, you get the slope. And the slope keeps changing. As x keeps changing, the slope keeps changing, because the slope is also a function of x. Right? Now you know that in order for the function to be the least possible value, the slope should be 0. So if you solve that equation for slope equals 0, you get the minimum value. So how do we get, so on the next line, you say, on the next line, you can say 12x plus 17 equals 0 implies 12x plus 17 equals 0. 17 equals 0 implies, implies x equals negative 17 over 12. Now, so far, is everybody okay with this? That means that the least possible value of the function is going to happen at negative 17 over 12. What is negative 17 over 12? Alexa, what is negative 17 divided by 12? Now open Desmos.
Minus 17 divided by 12 is approximately minus 1.4167.
Okay, minus 1.4167. Okay, this is the equation. I remember the equation. Now go to Desmos and let's plot that curve. Go to Desmos.
I'm having trouble here.
Alexa, stop.
Please.
Yeah, go to Desmos. Go another tab. Go to the Desmos tab in your Chrome browser. Yeah, and now I saw the tab. Yeah. Oh, you copied that. Okay, great. Yeah, thank you. You can say y equals that. Y equals and paste. Y equals. Now I remember it. We can type it. Yeah. So it's not dy by dx. You want to say y equals.
I think the video's a
Okay.
little behind. I got the Y one there.
There you go. All right, now zoom out so you get the whole curve, and let's go to the minimum point. Pan up. Okay, now mouse over and find out what the y value is. Okay, right. The minimum value of the function happens at x equals negative 1.417, right? And what was 17 divided by 12? I forget. I think it was negative 1.4417, wasn't it?
Yeah, the same
Alexa,
one.
what is negative 17 divided by 12?
Minus 17 divided by 12 is approximately minus 1.4167.
Okay, there you go. All right. So using calculus, we found that when x equals negative 1.417, the function reaches the minimum value, which we've actually found to be true in Desmos 2. Yes? Now we want to discover this. We saw this visually. We proved it with calculus. Now we're going to find it computationally. Okay, so now let's go back to your code. In the code, we're going to say, inside the code, in your main, you can basically say, open a comment saying, we will pick a random x value, find the slope at that, find the slope of the curve at that place. If the slope, on the next line, if the slope is negative, then we pick a new x value slightly to the right, right? Slightly to the right. If it is positive, then we pick a new x value slightly to the left. Is that correct? So if it's negative, we need to move to the right. That's a negative, and that's positive. Yeah. And if it is 0, we have reached the minimum. If it is 0, we have reached the minimum. Now, does this qualify as a computational approach to finding the slope? No, finding the minimum of a curve, which previously we were only able to do visually and mathematically using calculus. Okay, we did it visually, mathematically with calculus. Now we're going to do it computationally without knowledge of calculus. Are you guys okay with this? Okay, and are you convinced that this approach that we just put in comments there, Tim put the 4 lines of comments, right? Are you reasonably confident that approach will actually work? Well, you know what? Nobody's actually speaking up at all. It looks like nobody's confident, and you got to let me know. You got to get me some, give me some information, okay? And stay in step with me.
I feel good about it.
Okay. Well, one person at least. I hope others too. Okay. So all right. So on the next line of open, say double x equals. One more blank line actually. You can we'll start with logic. Yeah, double x equals, and we'll just say pick a random number. Let's say -5, or minus 5. Let's say -5, right? Or you just say 5. We don't know, right? Just say 5. Okay. All right. No, double x, not 2x. double x. All right. Double data type. No. Hey, Tim, are you playing with me? All right. Okay.
Right.
Okay. Double x equals 5. Okay. All right. Now semicolon. Enter. Okay. Now we'll say something. All right. All right. So now let's start a while loop. Okay. Let's. All right. So let's start a while loop. Okay. Let's just start a while. Say while true. While true for now. While true. Right, and we're going to change all this later. So in here, what we're going to do is put a comment there saying calculate the value of y for x equals for x and also x plus 0.1. right? For x and also x plus 0.1. Yeah, okay. So now let's say y1 equals y1 equals 6 x1 squared. That's 6 times 5 squared. Oh, 6 times x squared. 6 times x squared. 6 times x times x. 6 times x times x. Plus 17 times x minus 32. Yeah. Okay. Now calculate the y, and then y2 equals. No, I said double y1. Okay, not y1. Double y1. Double space y1. And now you also say double y2. Equals 6 times you can copy and paste it, we'll change it. Yeah. Now change all the x's into x plus 0.1 and the x plus 0.1. No. Change all the x's. Change all the x's. No, you can leave the 32 there. No, get rid of the plus 0.1. Why did you put it there?
Sorry.
No. Hey, Tim. I think it got messed up now. No, wait a sec. Put back the line as it was before, and we'll change it step by step. Okay.
Yep.
Okay. Right. Now change the first x you have into x plus 0.1 within parentheses. Change the x into x plus 0.1, and the x plus 0.1 should be within parentheses. Yeah. Thank you. Right. Now change everything else like that. All the x's should be like that. All of the x's on that line should be x plus 0.1.
I think the video is a little bit behind.
Oh, maybe. Oh, it's not. It's your internet then. It's not mine. Well, mine was also playing up, so I don't know what the hell is going on. Okay, now we got y2 and y1. Yes. So now on the next line, you can say double slope equals. On the next line. Yeah, video is playing up. Maybe it's in fact, you don't have your video on, and it's just this.
Right.
Yeah. Is it just me, or is it lagging for everyone? All right. Why? So double slope equals within parentheses. You say y2 minus y1. Divided by yeah. Now what is x2 minus x1? Tell me, what is x2 minus x1? Someone tell me that. The answer is there, right? Right there. Someone tell me what x2 minus x1 will be. Come on. What is x2 minus x1?
Is it X? Doesn't it just cancel out the other X and we just get one X left over? Or am I thinking?
Hey, Jose, you're very, I can't hear you all that clearly. Can you guys hear him?
I can hear him okay.
Yeah, I can hear him okay.
Oh, this is my volume then. No, my volume is all maxed out. Can you say that again, Jose, please?
Well, I might be too simple. Did the X like cancel out, so we just get left over with one X, or am I thinking too simply?
I'm afraid I can't hear you at all, Jose. You were like almost like a mouse. I couldn't hear you at all. Can someone else say something? I want to make sure that it's not just my speaker. Jaden, say something.
Is it Is it gonna, can you still hear me, or is it coming from a mile away?
Yeah, I can hear you. I can hear you. I can hear you. And my volume is maxed out. Alexa, increase volume. I don't know. Okay. But anyway, I think what Jose was trying to say was x2 minus x1 is simply 0.1, because what do we do? Your x1 was 5, and your x2 was basically 0.1, x1 plus 0.1, right? So x2 minus x1 is just at 0.1. Yes or no?
Yeah.
Okay. All right. So divided by 0.1, y2 minus y1 divided by 0.1. And put a comment there, because just because so many people hesitated, because x2 minus x1 is simply 0.1, because x2 minus x1 is simply 0.1. Yeah, okay, all right, good. So now we're going to make a decision based on the slope, right? So you're going to say, if slope is greater than 0, then we know that our minimum is to the right. Yes? No, actually, the slope is greater than 0, the minimum is to the left. So your x should go to that side, not this side. Yes? So all we're going to do now is we'll say if slope is greater than 0, let's say x equals x minus 0.2, right? This is a step in 0.2, right? Let's say 0.1, let's say 0.1, x minus 0.1, right? We'll just, that's, and this point, and put a comment on that line, on the same line, right? Put a comment. This 0.1, actually, let's say, say 0.01, all right? Just make it fine, right? 0.01. Okay, now say this 0.01 is what is called, this 0.01 is called a learning rate, right? Learning rate. And you can Google this for later, and we can talk about this later if you want. And it determines how quickly we reach the minimum, or also the risk is if it is too big, we can overstep the minimum and go beyond that. You'll find out all these as we experiment. Okay. Now on the next line, in fact, you have an extra space before the word slope. Right. So on the next line, you say if else if slope is greater than 0, else just say else if slope is greater than 0, else if, oh, you need I'm sorry, else if slope is 0. If slope is greater than 0, we got greater than, we need less than. Okay, yeah, there you go. Now it's plus 0.1. Okay, now so what happens if the slope is neither greater than 0 nor less than 0? Then we've reached the minimum, right? So else, you say else, next on the next line you say else, indent back, yeah, else, and then open curly brace. On the next line you say C out minimum reached at x equals C out, yeah, less than, left it, minimum reached at x equals and then the value of x after that, and end out. And then the next line should be break. We need to do one more thing before we can run it, okay? Because we're comparing floating point values, the odds that a floating point value will be exactly 0 is very low, right? It's very unlikely that a value in floating point will be exactly 0. So when you compare floating point values, you should never compare for exact equality to 0 and exact equality to numbers. What we need to do is simply find the intervals. So to compensate for that, what we're going to do is after line 27, hit enter. After line 27, hit enter. Here we'll say double 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 adjusted value, adjusted slope, right? Or no, we should say, what is value? Clamp slope. No, I don't want to use fancy terms. I'm trying to think of a simple term that we can use. Well, these values, I don't want to be, I want to clamp them to certain numbers. We'll just say adjusted slope, right? Adjusted, yeah, you got the right number. Adjusted slope. You know what? Okay, I'm sorry. What we'll do is a double diff, right? Let's just say double diff, right? Double diff equals the DIFF equals two F's, yeah, equals slope and absolute value ABS slope minus 0. Yeah, no, actually, yeah, just say slope minus 0, slope minus 0, slope minus 0, slope minus 0, right? Yeah, enter. Yes, semicolon, enter. Now, no, hang on. Yeah, I think that's fine. That's fine. Okay. Now, what we want to do is we want to do. All right. So in your line 31, get rid of the blank line. Let's go and do this in line 31, right? Line 31. Yeah, line 31. Where do you say slope greater than 0? Let's say if absolute value, right? So before the word S, before the letter S, say ABS, absolute. That's the absolute value. Open parentheses. Absolute value of the slope. Oh, you can't do absolute. Yeah, I think that's fine. Okay, absolute value of the slope. Yeah, if the absolute value of this. Oh, geez. Okay. Give me 10 seconds. Okay, I just need to think better about this. We have this value. If the slope is greater than 0, do that. If the slope is less than 0, do that.
Are we going to need to include a math library or anything for abs?
Yes, we do. We can include that later. Yeah, you can do it now. We can, and in fact, change the stdio.h to iostream also, right? And I'll think about this. If the slope is greater than 0, less than 0, else. Yeah, all right. We'll do the else in the last part. Yeah, okay. All right. So we don't need the absolute there, right? We'll just put the else on line, the abs on line 35. Okay. So on line 35, go to line 35. Yeah. So on line 35, where you have the else. Yeah, and then yeah, but there open a parentheses there. Yeah, inside the parentheses, you're going to say there you say absolute ABS. Open parentheses. Slope.
So wait, sorry, if I can ask, what does absolute exactly check for or make it?
Thank you. Do all right, I'm glad someone asked. Right, I was actually waiting for someone to ask that question because the first time I'm using absolute and nobody asked about it. So thank you, Jaden. Okay, absolute is the same as a mathematics absolute function. If you give it a negative number, it'll give you the positive version of the same number. Positive number, no change. Okay, absolute just takes the number and gives you the magnitude of the number. So if you give, what is the absolute of negative 0.5? It'll say 0.5. What's the absolute of 0.5? It's still 0.5. Does that make sense? That's why it's so absolute, right? If absolute value of slope is less than, so yeah, now is less than 0.01, right? So let's say 0.01 for now, 0.01, right? That's our tolerance, right? That's our tolerance. Then our minimum has been reached at x equals. I think that is fine, okay? Yeah, 1L tolerance is 0.01. Tolerance is 0.01, meaning that the slope can be anywhere between negative 0.1 and 0.01 for us to consider it to be 0. Right on the same line, you can say this means slope needs to be slope needs to be in the range negative 0.01 to positive 0.01 to be considered the same as 0. as 0. As 0. Now, does that make sense, everybody? I know there's a lot of nuances in here that you may need to pour over, even though there's only that much, that length. That program is completely functional now. I think we should be able to run it. In fact, you can run it now. You know what? Is it running? Kill it, by the way. Oh, math. Hash include math. Why does it not know about? Oh, CMath. Thank you. What is it?
Is it missing? It's expecting.
Oh, because we
Oh,
put
else if you're missing else if.
yeah, else if.
No, you're missing the if after the else. Yeah. What is this? Oh, standard colon end L, because you're not using the same namespace.
Looks like we have an infinite.
Okay. Well, good. Kill it. Control C. Or hit the stop button maybe. The red stop button.
Yeah, I hit
okay.
it. The video
now,
never mind.
Yeah, it's okay. So now, so it's going through the program, it compiled, but it's not printing the value, right? So what we want to do is put in a debug statement in line 30, hit enter, line 30, hit enter. Yeah, and then do a cout and say checking value at x equals and then the value of x and end L. And what we'll do is run it, and then we can run it and then stop it immediately so that we can look at the top few lines. Yeah, kill it. Right, let's look at the output. No, output is gone. Run again. Is it running?
Yeah, I see it bouncing between like 1.46 and 47.
Negative.
Oh, it's just oscillating. Okay.
Yeah.
All right. See, that's good. Kill it. All right. Kill it. All right. So that is the danger of using a learning rate like that. So what we want to do essentially is turn that x equals x plus 0.01 to x equals x plus 0.001, right? 0.001. Okay, run it now.
This one too here.
Same thing. Did you run it, Tim?
Oh, there we go. Same thing at a different decimal value.
Okay, all right, so to put in 5 zeros, okay? 0.001, right? 0.401. Right? Oh, wait a sec. Hang on. Let's see. Yeah. Yeah, let me try that. No, actually it is actually converging. It is converging. You see that it's getting closer and closer to the answer. What was the actual answer? 1.417? Was it 1. What was the actual answer? Does anybody remember what the actual answer was to the slope?
It's written right here. Negative 1.4167.
Oh, it was 1.4 something, right? So it should be getting there. It should be getting there slowly. But you see what's going on, right? It picked a 0.5, okay, found the slope there, And then, well, the slope was too much. So I'm going to move here, move here, move here. And it's gradually moving to the left and it's checking the slope at every point. When it comes to the lowest point, it'll see that the slope is actually 0. And it'll say, I found the slope, right? So you'll see that happen here. Now, this is a technique. It is very common in machine learning, okay? So later on, after you complete CS2C, and when you go on to learn data engineering and machine learning, this is one of the fundamental techniques you'll learn in the first week or so of machine learning classes. And as you can see, there's no rocket science to it, right? You understand this, right? Does everybody understand what we just did? I don't know, not everybody's nodding your heads, okay? Kiki nodded her head. I think Tim probably understands it because he's doing it. Kate, are you good with this? Do you understand what's going on? Jaden, you good? Adam? Okay, so how come you all nod your heads when I ask you specifically, with your name, but when I say, does everybody understand it? Nobody's nodding their heads. Okay, so you just feel free to nod anyway, okay? So here's what's going on. Oh, it needs to get to 1.4. That's where it'll either start oscillating or it'll stop, okay?
Gotta get to negative.
All right, getting closer and closer.
We're still in positive.
Oh, wow. Is this the, why
We're
did it
still in
pass the point?
positive 1.4. It's trying to get to
Oh,
negative.
we need to go to negative. Oh my gosh, I totally forgot. Okay, all right. So you can see, you can see that, you can visualize the curve and you can see where you're checking. You're checking here, 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 here. We're getting closer and closer to the, negative 1.417 or something like that.
I think we probably could have taken.
Why is the program slow down? Did your program slow down by any chance?
Looks like roughly the same speed to me.
Yeah. Oh, for me, the screen, your program seemed to have, I thought maybe, online GDB is throttling the program. Any program that runs for longer than 5 seconds, it's possible that they're throttling it. But we're getting there. minus. Oh, now it's fast. Maybe it's just a buffering issue. Maybe we should have used a smaller learning, a learning rate that is more conducive. Does anybody remember what the actual value was? Negative 1 point something.
It's still written on the top here. It's 1.4167.
Okay. Negative 1.4167. We should see that value come up soon, hopefully. 1 point. Oh no, it passed it. It passed it, did it? What was the value supposed to be, Tim?
Yeah, it is a little bit past, but it's stuck at that.
But it's not oscillating so much, right? It's actually gone to the right place now.
Well, it's still oscillating, but it is kind of the wrong number, though, isn't it? Maybe our math.
No, it is. See, well, what's going on is that it's gotten to the place, right? But when it got to that place, it's kind of oscillating very close to that number. It's not moving past. Like it came from -5 all the way here, but here it's not going at the same speed, right? It's now oscillating very closely in that place. Yes or no?
I'm just saying that our math must be a little bit off because it's supposed to be 416 and it's oscillating at 466.
Oh, it's oscillating at 466. Okay, all right. Anyway, what time is it now? Because I don't know if I should give you more information about this. You can kill it now. Okay.
It's 9:45.
All right. It's 9:45. You got 10 minutes. Okay, you got 10 minutes. I would like you guys to play with the numbers and think about what's going on and try and get it not to oscillate. You want it to settle down. Okay, you want it to settle down, saying that at this place, when I calculate the slope is so close to 0 that I can break out of the loop. Okay, so we want to get it to that place. Are you guys comfortable and confident about doing that? Right? If you are, I can basically, turn the laptop around so I'm not in your face, but I'll be hearing you. So can you do that? You have to fiddle with the numbers, the learning rate, and also think about the curve and what you need to change and what's going on in the output. and try and make it run so we can actually get it to narrow down and exit with the right condition. Can you do that? It's just a matter of fiddling with the numbers and trying to figure out what you need to do to get it to converge. Already we did that, right? We took, we took some numbers and we said, oh, let's change the learning rate and some things like that, and got to better performance, not performance, better accuracy. So can you do that? It is just a simple matter of fiddling with the learning rate and things and the condition for you to narrow down into the exact place where the minimum exists. Are you confident doing that? Right? Because if you can do that, you're basically set up to ace your first machine learning class on gradient descent, right? Because this is gradient descent. Except there you'll be applying this to a surface that you can't even see. In this case, it's a parabola you can see, so you can verify things visually, right? When you go to actual machine learning class, you'll get a complex surface. This is the error of a neural net, right? With 5,000 variables. And you got to find the minimum error. What do you do? Right? In that case, what you'll do is, rather than actually do the slope calculation this way, you'll take the partial derivatives, right? There you'll go to calculus and use a derivative equation and find out, right? And find this is a slope, so I need to go this side or that side, right? And do that. Exactly the same. Exactly the same. If you understand this, you will understand how to do that. Okay, and it's an advanced concept, but it is within grasp of CS2A students, in my opinion. If I'm wrong, please let me know, right? If this is beyond the grasp of CS2A students, let me know so that I won't burden next quarter students with this exercise, which I thought was really cool exercise for CS2A students, right? Because it is a search technique, right? And it is searching for a value that you don't know, as opposed to a value that you know. So it's an advanced search technique, and it uses gradient descent, which you'll only learn in advanced computer science. So are you guys happy? Can I now leave the code in your hands, turn the laptop around so that I'm not in your face? Will you guys be able to vocally, right? Again, no silence. Keep talking, even if it's bullshit, I don't care. Yeah, sure, Kiki.
Yeah, so on line 29, the double diff is slope -0. Like, what does this mean? Like,
line 29.
Slope
yeah.
-0.
I'm sorry, get rid of line. Like, we don't need line 29. I'm sorry. Kiki, thank you for pointing that out. Okay, we're not even using diff. Get rid of line 29. We don't need it. No, you can delete it. You know what? Because what we're doing there is just -0. A number -0 is the same number, right? Yeah. Is that what you were saying, Kiki?
Yeah, right. I didn't understand why there's -0, like the same number.
Yeah. I was trying to do something crazy there, something different, and I realized we backtracked and forgot to delete that out. Okay. So any other questions?
When I try to run the code, I code on my laptop, and when I try to run it, it like runs faster than Teams code. I don't know what's the speed depends on. Is the laptop?
Oh yeah, obviously it'll run much faster on your computer.
Yeah,
Tim is running it on
GDB
online GDB,
okay,
which is a shared computer used by millions of users. Well, probably thousands of users, right? So
okay,
that's why it's slow.
Thank you.
So can you guys figure out? Can you, even if you don't manage to figure it out in class, you can share this and say we tried to do more and figured it out, and here's the code and output and everything. You can share this on Reddit, okay? All of these things qualify for extra credit. I don't know why nobody's picking up these opportunities, but you can share this on Reddit also and say these are changes we made and this is how it works. And also share your insights on this is gradient descent. I learned something called gradient descent, and this is what it does. And in my own words, try and explain it. Right? You get points for that too. Right? And it is a search technique that we mastered in class today, or learned in class today. All right. Do you want like 5 or 10 minutes to just fiddle around with this code and try to get the minimum? Yes or no?
Yeah.
Thank you. Kate, Jaden, you good? Okay, Jose?
Yeah, I'm good.
Okay, all right, excellent. All right, just call me, okay? Call me if you need my help, but otherwise I'll expect to, hope to hear your voices for the next 5 minutes at least, okay? As you're trying to fiddle with this code. Thank you, guys.
I'm going to try taking one of the zeros out of the learning rate so it'll go a little faster on online GDB. Hmm.
Do you think we could create probably a new simpler or easier?
Does the like I had a question about does the tolerance change like how fast like where it oscillates? Like I'm kind of confused on that.
Yeah, I'm wondering if that'll make a difference too. Because that's where it's testing too. I wonder if that's why it's getting 466 instead of 416.
Yeah.
So it's going 100 right now. It seems like it's going 500 above the number before it stops. Oh no, wait. Why am I reading that wrong? 200. It stops 200 because it's stopping at what 4667.
Yeah.
Mm-hmm.
Do you think we should probably have a way to make it automatically end when it reaches 4167? Do we have to have it do it naturally?
I was gonna say like if we change the tolerance, if we made it 0.1, how would it?
Yeah, I wonder this too. Probably like faster to reach the minimum value.
Yeah.
So bring it to 0.001 or 0.1.
0.1, I think. Like
0.1.
high 0.1.
I could start at something lower than X, so it's not counting all the way down.
Okay.
Let's give it a minute.
I always think it's positive.
Still 6.6.
Yeah, still the same.
Weird. Hmm. Let's check something. If I started at -5. Yes, it'll count down.
I'll try from X equals 0.
So it's the same thing. Yeah, either way, it'll increment or decrement it to get it to the 1.46. But where is it getting that? Second 6. So if the tolerance was smaller, like 0.001, would that be checking? It's checking the slope at a smaller. So slope at 1.46.
What if tolerance was at like 0.0001, like an extra zero? I don't know if that would. I don't think it would, but I don't know.
Yeah, let's check. But yeah, it doesn't seem like that's making a difference. And somewhere in the math, it's getting this 6.
Yeah.
So if we have 1.466. It's doing it here. 6 times x squared.
Calculators. Six.
So in that instance, it's getting that for y1. I got to do all that for y2 also. So that would be, oh, could it be, do we have to mess with this value here?
I
That's all.
think- Yeah.
All it's adjusting right there. What do you guys think?
How many decimal places should we like try?
Mm-hmm.
So, sorry, if I can ask, what is the 0.1 exactly doing? Why not use just like a regular? Oh, yeah, I'm reading it now. Sorry, stupid question.
0.1. That's what's. So put that into.
Would maybe like for the 0.1, if I was thinking if it was like really small, maybe it would get us that much closer to 1.4167 is my guess. But I don't know. I'm really confused on this.
I'm having a hard time visualizing it too. Really, if we just did this. That'll work.
Oh, I think it's closer because it was 466.
Now it's rounding up to 2, maybe at that point.
Yeah.
So we get the same number of zeros here than with the checks.
Mm-hmm.
That's better.
Oh, yeah.
Okay. So maybe if this is one more than the check, then it'll be within the range that it's
Mhm.
checking for tolerance. I don't know, maybe.
Yeah, I think so.
No, but it still keeps trying.
Yeah.
Wonder why. So if the absolute value taking x so yeah, the slope. Oops. A little less.
So,
Yeah, I don't get it.
maybe it's the learning rate that we need to change too, instead of the tolerance. Because remember when we first tried doing tolerance, it didn't work, and it didn't really make a difference. Because I'm trying to think, but I don't.
You want to try this at a larger number?
Uh, I, yeah.
Wait, try that.
Oh, okay. So I'm guessing the learning rate's just gonna give us the decimal place of the answer.
Yeah. Yeah, the learning rate is how much we're adding or increasing each check.
Yeah.
Adding or decreasing. It's fine there or at the other value, but so right here in the, it's not breaking. It's not giving true for this. Oh, hey, well, I don't think the slope will ever be less than that when it's divided by 0.01.
Mm-hmm.
I wonder if see at this point I'm not able to like do this math in my head, and I'm kind of just guessing here. Yes, no difference there though. But .1. At least we got the number closer though. It's 10 o'clock. Does anybody have any other ideas, or should we ask Professor.
I think the endless at the end to be missing.
You guys are still here after class. They're trying to figure it out. So I'm all right.
We've gotten close.
Great stuff. Did you manage to converge, by the way?
We got to negative 4167, but it's switching between 416 and 417.
Yeah, we can't get the
Oh,
check
it's
to
oscillating.
pass here.
Very good. It's very good. You've narrowed down the range, right? You've narrowed down the range so that your potential minimum is very close to the actual minimum. Yes?
Mhm.
Okay, so that is something we have to get used to in machine learning, and not, because that's something we never get used to in mathematics, right? Those of you who have a mathematical mind will know immediately. Oh my gosh, I don't even want to go there because it's horrid territory where you can't have absolute equalities, right? Yes, because in math we're always looking for absolute truth and exact equalities. But the thing that characterizes machine learning, if you want to go down that route at all in your life, is that you have to be content. Right? You have to develop a satisfaction for something that is possible versus something that is conceivable, right? Perfection is conceivable, but may not be possible all the time. So that we have to learn to live with what is possible. And here in machine learning, that is why we have tolerance and say, we don't want a slope of exact zero, because the exact zero slope I can get with mathematics. If it's possible. Sometimes in mathematics, it's not possible also, right? Even using calculus, it's not possible for certain surfaces to determine the exact zero. So even in those cases, in the real world, we take tolerances, right? If you take a Tesla car, any auto driving car today, any Google or using machine learning, all the decisions being made, even in the Pentagon, right? Even in Pentagon and defense in multi national places. Even there, if they use machine learning, they cannot identify exact solutions. What they will identify is a solution that is very close to the exact solution, and depending on the critical, the severity of the situation. If it is national defense, then you want to have the solution be, 0.59 or 100 decimal places close to the actual zero, right? If it's, something that you can do with whether I should go to Trader Joe's or buy a stock today or tomorrow, something like that, then you say, okay, 9 decimal places is enough. Here in this case, it's just experimental play. You can say my tolerance does not need to be that high. I can have a tolerance of, even a reasonably big tolerance. I'm happy to break out of the loop. So you can say if the absolute value of the slope is less than 0.1 itself, you can exit, right? If the absolute value of the slope, and also you can print the actual value of the slope in your where you say print the value of x. You can also print the value of slope. You can say, yeah, x equals this and slope equals, right? And then before the end L, you can say and slope equals slope also, right? And then you'll actually see the value of the slope, and you'll see where you can break out of the loop. Before the end L, has to go before the end L. Yeah, okay, next line is fine. Slope equals. Yeah, next line is fine too. But you'll have 2 lines of output then. Yeah.
It might be more readable if
get
it's
rid
on
of
the same line though.
Just say, get rid of that and say a code, comma, slope equals, and slope. Yeah. Right. If you run it now, we'll get a rough idea of what slope you need to break out of the loop. Right. So, all right. So let's take a look at the slope. Oh, the slope is actually pretty low here, right? It's something times 10 to the negative 7. Why is the absolute value of that slope not less than 0.01? That's obviously less than 0.01, isn't it? Oh yeah, of course. Oh my gosh. There is a bug. Okay, I don't know if you guys see what the bug is. It is one line. Okay, it is one line, and the bug is basically just a structure of the if statement. You have 3 if else and else, right? It is just here's a hint. Okay, it is a huge hint. Anyone who fixes this and posts a solution on Reddit, I'll give you 2 extra credit points. Okay, you have to find out the reason for this, and the reason is this: it is only within that if statement, the 6 lines or 7 lines of if statements, right? The if statement, that's where the bug is, and it is just a matter of rearranging the order in which you make the comparisons. Okay, that's all I'm going to say. I'm not going to say anything more than that. If you just rearrange the order, you'll be good. Now, I won't say anything more than that. You don't have to do it in class. You're welcome to, but people are going to disappear because it's after 10. Man, doubtful, because you guys are still around. It's already past 10. So you're welcome to fix it here, or you can fix it in your own time. Either way, everybody who posts about this and a solution and some insight about this will get 2 extra credit points, okay, for your question. And so, in fact, let's not even make it question. I'll just add 2 extra credit points total, right? Which is actually worth a lot more than 2 just added to your question. I'll add 2 extra credit points total to your score, right? And that's even unscaled and everything, so it'll be very valuable. So you have to find out what the issue is and post it. It's very simple, okay? Very, very simple. Does not require math or CS or any other language knowledge. It is just what you've learned so far in C++, and conditions and testing and what order the testing happens and if statements. So it's actually branching and looping, right? This is about branching and looping. If you can find the bug and fix it and share it, and also say, hey guys, we got this program and we got it to work, and it's really cool or something like that. Okay, that's it. I think that would, and you don't, even if someone else has done it, you can still post it and still get extra credit. Okay, it's not like the first person only gets 2 points. Okay, everybody who posts will get 2 points, even the people who are not here. If they implement this and post it and say this is a completed program, and this was a bug I fixed and it works now, it'll be cool. And also, if you want to get to the answer sooner, you don't have to start all the way at 5, and inch slowly towards the, because we know it's around 1, you can actually start at 2, it's for debugging purposes, it'll be easier. And from 2, it'll go really quickly. Maybe you did that already. Yeah. What did you say? Double X equals, you said X equals 0 on top?
Yeah, we're just kind of down from 0.
Oh, cool. Yeah, that's even better. That's even better, because you start at 0 and then you only have a little bit to cover, not starting at 5. No, that's great. Okay, thank you. Now, do you want me to tell you the answer to this? I hope not. Okay, because it's very simple and it's going to be instructive for you to figure out. But Adam, you're saying, you're shaking your head. Do you want me to or no?
No.
No, I think I've got a guess.
Oh,
too.
thank you. All right. Okay. All right. I guarantee that if you find it on your own, you will feel a thrill. Okay, you'll feel that you've actually mastered something really cool. Once you find out what's going on, rearrange things and get it to work and share it, you'll feel good about it. Okay, no matter if other people have done it already, do it on your own, post it, you'll feel good. Okay, and if nobody gets it, ask me in 4 or 5 days and I'll help you. Okay, I'll absolutely do that. Next class, we'll start talking about searching techniques on Tuesday. No, not searching, sorting techniques. Maybe we'll start with a very simple bubble sort, or some very simple technique like finding a minimum and yanking it to the top repeatedly, and then we'll calculate the number of times we have to compare elements and so on. And then I'm going to give it, at that point, I'll give it to you guys and say, now here's your basic sort, right? And it's taking n squared number of comparisons to give me the sorted list. See if you can make it better, right? Less than n squared. Can you do it in fewer number of comparisons? Okay, and that will be a challenge, and we can noodle on that. Lots and lots of interesting and exciting work hidden in that landscape. Okay, so we can do that. We only have 1 week for sorting, and I think that's more than enough, really, because in 2A, it doesn't go into great detail of the juicier part of sorting. Right, so we'll do that next week, and the week after that we'll do linked data structures, pointers, and then implement a stack using linked lists, and then a linked list after that, and that's it. Right, that's the end of this class. And also I hope that you guys will continue to do my 2B and 2C. I said this before, mainly because I'm also seriously thinking about retiring at some point soon, because I got a bunch of projects of my own that I want to make some progress on, including stuff in open education and all. And I think if I retire, I'll have more time to do those things, which means that the C++ sequence or any course that I teach, the questing way of doing it may only be offered for a few more quarters. And so 2B and 2C, if you still want to continue to do the questing and with me, I think you should basically do it as soon as possible, because It's not like immediately, but I'm thinking maybe, after the end of the next academic year, because that'll give our department more time to find a good substitute and hire them too. So we'll see how that goes. So that's please do enroll in 2B and 2C and pass the message on to other people in class also, that if they want to do 2A, BC using this particular way of learning, which is questing and coding online and things like that, I'll only be teaching it for a little while longer, maybe a year or two max. So please do it before then. Otherwise, there's other sections on offer elsewhere. And I think I'll offer these classes for free anyway on LinkedIn and social networks. I'll just say, get 10 people together, I'll teach it. Right? I've already made that announcement on LinkedIn. Just say any 10 people anywhere in the world, right? Maybe 2 people from China, 2 from Africa, 2 from India, 2 from the US, Europe, all of them together, 10 people, right? And there's a class, but they all get together at the same time, like 8 a.m. on Tuesday and Thursday. I'm happy to teach this class for free after I retire too. I can do that even now also. So I'll continue to do that, but teaching for credit and for getting units and a certificate, I think those days are probably numbered. So please, if you want to get credit for this in a college system, please consider enrolling and finishing off these courses. Thank you all so much. Was this class useful? Did you actually get something useful out of this? Interesting? Yeah, I know you all just nod your head out of politeness, or I don't know, but don't nod your head out of politeness, okay? Because it doesn't matter because if you didn't learn anything, it's actually useful information for me, right? Because then I can know that, oh wow, that didn't work. I should try it next quarter. On the other hand, if you say yes, that was useful, I'll try it again next quarter, and those students also will be, if you were disappointed, that is. So, but I'm glad, I'm glad you guys stuck around even after the end of class. You're sticking around, trying to debug the problem, came up with solutions and so on. So, and I think, that I'm very pleased to see that. I would like to see this program completed. It's only a short program, completed, shared on Reddit, also with your own thoughts on this, right? On your own thoughts on how you think it would be useful and things like that. It would be fantastic. And it'll help you greatly, okay? It'll help you greatly. Imagine, right? Some future recruiter who Googles, your name, Tim or Kate or Adam, and they come across this post saying, hey, when this student was a first year, they made an insightful comment about gradient descent, right? And how cool would that be? And that basically gives you a huge edge over other job applicants who are looking to get employed. So there you go. I think these are great opportunities for you. And while our Reddit is still open, and while I've not moved all the discussions over to closed canvas, so where you make comments that are going to evaporate at the end of every quarter, right? This is your opportunity. We can make a comment and have it live on, so that will benefit you down the line, years down the line. So please take advantage of that. Thank you all. Okay, I'll see you on Tuesday, hopefully. Please continue blowing ahead and sharing your insights on Reddit. You have the weekend complete programs, okay? It shouldn't be like after this class, the next time you're going to be, encountering CS2A is only on Tuesday. And it shouldn't be like that. If you're, trying to learn, you have to be on it all the time, have to be thinking about it all the time, right? And you'll get better and better. And eventually you'll be thinking about it, even if you don't consciously think about it, you'll just be in that mode of thought, okay? Your thinking pattern will change so that you're consider all possible ways of solving problems. Thank you guys very much. And I will see you on Tuesday. Have a good weekend.
Thank you, Professor. Class 7's really something, but I'll keep trying to pick away at it.
Yeah, no worries, no worries.